Good morning, and let's start. So, do you have any questions from the previous sessions? Any doubt?
Yesterday I asked for the recording and none of
Okay,
I didn't receive.
yeah, you get that today. No
You
worry.
you the recording you just download and then you are free to go. But what is in the recorded version,
Okay,
you need
okay,
to
okay,
you need to watch. It is not permitted to download. Understand? And then
okay.
in,
So,
internet is not cut across. So access to get internet in some way. So if you have a recorded version, you go to one place, you can just have
okay,
it watch.
no problem, no problem. So, I understand. So, you accessing the recording session on the portal, right?
Yeah.
So, your video is not playing. You're saying like that?
No, it's not like not playing. On the website, internet is not. I'm saying that the internet is not cut across whereby. So
Okay.
in terms of watching, it's another problem. Unless I have access to internet before I can watch it. But
Okay. So,
if the recorded like what we did yesterday was uploaded to me, like I can download and then be watching it at any point in time.
okay, got it. So you want download. So I'll talk for that. Okay, I'll get back to you. Okay.
Okay,
Because
okay.
only one portal we have where you can get the video and you can watch that, and that require the internet. That's mandatory.
Yes.
You're
That is what I'm
looking,
saying.
yeah, that's you're looking for the something which is going to be downloaded and you want to see that, right? Okay, so no
Yeah.
worry. Let's understand on the concept. We'll discuss this one later. Okay.
Okay.
Okay, so yesterday we discussed about the concept like zone, right? And we understand some basic idea, right? Also, we did understand how this my NAT policy are going to be impact to make the communication on the internet. So, do you have any questions from the last two class, or is
No,
it
no, no,
no?
no.
Okay. So, what I'm going to talk today, we are going to discuss about the NAT and the security policy.
Okay.
Okay, so we are going to talk about these two things today. So first we'll try to understand what is the security policy and how it is going to work. So we are going to talk about the security policy. Do you know anything about the ACL?
Yes.
Okay, you know the ACL, right?
Yes.
So similarly, ACL have the limitation, but security policy have the more flavor in terms of the just understanding the packet whenever it is going to process by the Palo Alto Firewall, Fortinet Firewall, or any other firewall, they have the more parameters to understand. Means the ACL generally work on the if have the any IP packet, the IP packet have the multiple informations. They have the layer 2 informations, they have the layer 3 informations, they have the layer 4 information, they have the layer 7 information. Let's suppose you're going to add any URL, you are going to add any user ID as well, right? Some additional field, and then you have the data. That's actually your payload. So these all information is going to be inside of the any packets. That's your any kind of packet is going to hit to the Palo Alto firewall, any other firewalls. So ideally, when I just go and configure the access control list, they operate on the layer 2. They filter the MAC address. They operate on the layer 3. They filter the IP address. And also they work on the layer 4. They filter the port numbers. Clear? So
Yes.
these three things are going to be only monitored in top of the ACL. But when we configure the policy have the more granular restrictions or more features. Means they can understand the your layer 2, that is the MAC. They can understand your IP layer 3. They can understand your layer 4, that is your port number. Also, they understand the layer 7, that is going to be your any kind of the applications. 5, 6 I'm not talking because TCP/IP generally combine all three layers is a one layer. That is a layer 7. Okay.
Mm.
That also going to monitor your any URL, any user ID if you are going to use, that is going to also any device type or device ID that is also going to be there. And then finally some other field and then payload. Means the actual content. Means these all parameter is going to match in my Palo Alto firewall when I'm going to configure the policy. But if I going to use the ACL, Palo Alto not support the ACL, they support the policy. But let's suppose I have the legacy firewall like Cisco ASA, they can do the inspection up to layer 3, layer 2 and layer 4 only. So this is my old firewall. So that's the difference between the ACL and policy. Okay. That's the inspection level. Now
Mm.
I just go and look inside of the policy of this particular Palo Alto firewall. So if I go here and I try to log in it, and if I just show you, show system info, that's a 37. So you just go and log in this 192.37. So this is going to be just logged in. If I'm going to log in, your firewall is going to be logged in, and I will show you what all features are available in terms of the policy. So just wait. So now if I go remind me later and policy. So in policy, if I just show you, by default, we discussed we have the intra-zone and inter-zone policy that is going to be available. But if you're going to create the policy, let's suppose we are creating the test policy. So in this policy, one section is known as the general. What is a general? General means why you creating this policy. So you have to give the appropriate name. It should not like you can give any random name. It should not like that. You must be give some logical name which is meaningful. Means why you creating this policy. What is the relevant of the policy? Let's suppose you creating this policy. Let's suppose from the policy should go from the my DMJ to internet. So you know my traffic is going to come from the DMJ zone and it is going to the internet. Similarly, if I am creating a policy from the trust to untrust, that means internet. So you have to mention the zone, right? Or
Mm.
let's suppose you have the department. Let's suppose in your company, you have the multiple department. This is the firewall. This is the PA01 firewall. Now this firewall have the connected with the HR department. They have the sales department and they have the IT department. So they are going to connect on the different interface on the Palo Alto firewall. So might be this is going to be your Ethernet 0x1. This is going to be Ethernet 0x2. This is going to be Ethernet 0x3. So this one might be have the 192.168.10.0/24, 172.16.10.0/24. This is going to be 10.10.10.0/24. They are the different network we have, right? But in the day, this firewall have the connectivity with the internet. This is my internet, and this link is basically Ethernet 0x0, and this have the IP address. Let's suppose this is IP address 123.10.10.1/24, and the gateway is like 123.10.10.2/24. Should be one here, two here. Okay, so you can put any IP address. So this is basically your WAN internet, but these are the LAN. But you have to define a zone here. So this is going to be my HR zone. This is going to my sales zone. This is going to my IT zone. So when you create the policy, when you create the very first policy, you have to mention the meaningful name. Like let's suppose HR want to go on the internet. So you have to put HR to internet. Okay, this is the name, right? If you're going from the sales, then you have to put sales to internet. Why are you creating a policy? Sales want to go internet. If I want to go IT to internet, then IT to internet. Meaningful, right? But let's suppose my
Yes,
HR want to talk to sales. Again, the policy is going to be required. Without policy, they cannot talk. So my
yes,
policy is going to be this way. So in this case, my policy is going to be HR to sales. This is my policy name. So you always have to define a policy which is a more meaningful. It should not like be you can give any random thing. It should be meaningful. You always define the meaningful policy name, then only it is going to work. Clear? So here if
yes.
I'm going to, let's suppose my trust want to go on the untrust. So I'll put test policy, test policy or lab policy, anything you can put lab policy from trust to untrust. Untrust is something you are going to the internet. This is the first thing you have to put it here, name. Now there is another term, universal intrazone and interzone. Okay. So what is
Yes.
the rule type? If you're going to configure rule type, you have to define what is the rule type. It should be the universal, default one. You can say it is a default one or interzone or intrazone. So 99% case, whenever you're going to get the policy, you are going to find this is going to be 99% case, the universal default is going to be selected. And this is going to be very flexible. It's going to be very flexible. Means this allow you can create the policy interzone and intrazone both. It is going to allow you can create the policy for interzone and intrazone both. But if you want to purposefully use, if you want to purposefully use an intrazone, then what is going to happen? An interzone, then what is going to happen? So if you are going to select the universal, that means under the source, you can define the zone name like trust. Destination, if you want to define the trust, it is also possible. In source, if you want to define the trust and destination, you want to define untrust, it is also possible. Means universal is very much flexible. Same zone can be in the source and destination. Different zone can be source and destination. But if I selected my intra zone, that means whatever the source zone I'm going to put, by default destination is going to be same zone. Let me show you. If I'm going to select the intra zone, so if I select the intra zone here, and if I'm going to trust, I'm going to select the source in the trust. You don't have opportunity to make the different zone in the destination. It will by default inherit exact same zone as a source because intra zone is the same zone.
Okay.
Intra zone is equal to means you
Same
want
goal.
communication within the same zone. So that's why I selected intra zone. So source is going to be my trust. So destination also going to be trust.
That's what.
Clear?
Yes.
Super clear. Now, but if I select the universal, if I change it to universal, you see, I can change the zone. Either my choice, I want to make a trust, I can do that. If I want to make untrust, that is also possible. I have the flexibility. But again, I select the interzone. Then what is going to happen? If I am selecting the trust, sorry, go ahead.
Go on. Go
So
on. You can create a policy.
I can create the policy, but this policy is saying one side you have a trust, another side you cannot put a trust. If you put a trust, it's going to be meaningless. You have to make a different zone because you selected the intra zone, means interzone. Interzone always going to require the different zone. Make sense?
Different one. Oh, yes, yes.
Yeah, so this is how you have select, but most of the case you have to select the universal default. Clear? So this
Mm.
is something about these two tabs. What is descriptions? Description is about what you are going to do the policy. Means why you are creating this policy. What is the use of this policy? Okay.
Yeah.
This is going to be description. Means anything you are going to use for the policy that is going to put under the descriptions. Let's suppose I am creating this policy. I can put anything. This policy for lab testing. Or might be, let's suppose, take an example. You can create this policy will allow communication from trust subnet to untrust, that is the internet. And this will specially used in GoNet lab testing environments. Right? So you can put anything. So one who is going to review this policy, they can understand why this policy is created. Great. And then you
Yes.
can tag, you can group them policy, and someone is going to audit. So you can put that policy has been audited by GoNet Palo Alto expert. You can put anything. Then this is going to be your gender. So just going to be give the gender information. Now, if I'm moving to the next one, we have the source as zone. Source zone is something I have to define the zone for the every, like whatever the interface is, whatever the firewall we created, that zone is going to be defined. In zone, you have to make sure you define the addresses. So you have to put the addresses, that is your source addresses, means the subnet. Let's suppose this subnet is going to come. This subnet is going to come from this area. So you can put the whole subnet name, means IP subnet. 172.16.10.0/24 is my subnet. User, if your AD is going to be integrated, then user is going to be there. So in my case, AD is not integrated. So right now it is not going to see. But later on, you will see that how AD is going to be integrated. And then finally, we have the destinations. Means source device also have the options. You want to integrate any devices, like for any device specific, you want to define a policy, you want to match the 3D printer, you want to match for the automations, you want to match for the camera, you want to match for dental devices. So we have the lot of IP phones, IT servers. So there are a lot of kind of devices which can be matched and can be used for the your any kind of the device level. Even you want to match for the OS, like any OS level restriction you want to put, iOS, XP Shadow, Air OS,
Windows.
Wave OS. So this also it is possible. 40 OS. You want to apply for the models as well. So there are a lot of models number we have. OS version you want to apply, Android. So that have the vendor you want to apply for any vendor. So you have the lot of opportunity to restrict your traffic based on the device as well. That's a completely possible. Clear? Source
Yes.
user basically based on the department username, department user groups, department any kind of the any special user who want to access certain website, who don't want to access certain website. So you can always go and basically define that, and it is going to restrict your communication or allow your communication. So you have the lot of flexibility to define what need to be accessed and what not need
Not
to be
to be
accessed.
accessed.
Yeah, okay. So this
Mm.
is source. Now, if you go to the destination, again you have to define the untrust. But if this user want to go on the destination, they require the destination have the one than more than 1 million routes, means 10 lakh routes in INR. So more than 1 million route means you cannot put all 1 million route in this particular Palo Alto firewall. This is going to be dead. So if you want to avoid the situation, what you can do that? You probably have to make sure my traffic should come to the my Palo Alto firewall. And after that, we have the one of the default route, which is going to the internet, which is going to be acting as a last gateway of resort. And that is going to process my traffic. So I can put any destinations and I will define the one of the default route also. And destination device also, I'm not going to select anything. Application will talk later. I'll just put any right now. Services, I'll put default. Action, I'll put allow, and then I'll create the policy. Then my policy is going to be created. So one thing you understand in this policy, you understand layer 3 addresses. I mentioned in the packet, we have the multiple informations. So let me
Yes,
draw this packet. This packet, we have the layer 3. We talk about the layer 4. We talk about the
yes,
layer 7. We talk about the URL. We talk about the user. We talk about the devices, right? Some
yes.
additional feature, and then we talk about the payload. That's the my data. So where is L3? This is your L3 address. Okay, clear?
Yes.
Zone
Yes.
you ignore. Now if I go for the destination, this is again your L3. You can see this is again L3. Devices is going to be there. In source also you have devices. If you click here source, you are going to find the devices and user also. So you can see this is the user. So this is the user. It is going to match here. Clear? So you have
Yes.
L3, but still L4 is not there, right? L4, I mistaken. L3 is this one. L4 is somewhere else. L4 is this one. Let me show you. L4, you go for the services.
UL.
This is the L4. This is the L4. If you're creating any HTTP traffic, HTTPS traffic, this is going to be your L4. Clear? So your L4
Yes.
is going to match here. This is my L4. That is a port number. Clear? Now
Mm.
L7. L7 is going under the application. See, this is the application. So like you want to match some Facebook applications, some Gmail application, some WhatsApp application. So this is going to match my, you just go and select the WhatsApp. So WhatsApp is one of the application. So you go and select it. This is the one application. This is going to match in the L7. Where is the URL? URL is going to be here. So this is going to be your URL. If you go here, this is your URL. Clear? And
Mm.
where is the payload is going to be checked. So if you want to check the payload, which verify L3, L4, L7, URL, user, and device. Clear? Still, we
Yep.
have some additional feature and then the payload, where the payload is going to be checked. So if you want to check the payload, you have to go in the actions.
Okay.
You have to go in the profile and here is the payload. You go in the profile and in this profile, we have the different options, which is going to verify my entire payload. Means the device is sending, receiving any packets, Excel file, URL, attachment. They might be have the virus. They need to verify by using the antivirus. They might be have the vulnerability. They need to verify with the vulnerability protection. They might be have the antivirus, URL, file blocking data. So everything is going to check here. And now if you want to attach the QS, that is also possible. And that is going to be additional parameter is going to verify. So we have a lot of thing to verify. See, and everything is going to available in my policy. Make sense? Clear?
Yes.
Any
Yes.
doubt?
No.
Okay, very good. So I'll keep it no, and this is all information. I'll just let me make as a default any. Let me make as a default. No need this one. This all is going to be same. I'll get this policy. So this is the how policy is going to be created. Now, in policy, we have the different sections. Now moving to the next part. We have the another requirement. As we discuss even, if I want to go on the internet, I need the three things. The very first is going to be always required is the routing. If routing is not there, you cannot do anything. Second is going to require the NAT policy. Third is going to require the security policy. And we discussed right now what is security policy, right? You clear about
Yes.
this?
Yes.
Now, if anything, if any user sitting in the on any private network, if I am in the private network and I want to access the internet, I required these three things. If either it is going to miss, my LAN through internet communication is not going to be happen. This is my Palo Alto Firewall. This have the internet, right? If they want to go on the internet, they have any private network, they cannot go until we apply three policy.
That's
So now security policy, we understand how basically we can create a security policy and what parameter we can match. Now we have to focus how the routing is going to be there. As I mentioned, if you go and check the internet, we have the more than 1 million route. Means more than 10 lakh routes available on the internet. 1 million plus route is available on the internet. So if you want to get all route on your Palo Alto firewall, might be your firewall is going to be crashed. It's going to be dead because they not have the capability to handle that much route which is going to be come from the internet. So that's why on internet, when we have the ISP router, they are very big router, ASR router they use, the ISR router they use, and even more than bigger router they use to just handle the bigger routing table. To handle the bigger routing table, so your backbone is going to be always robust and scalable, and they process routing effectively. But if my Palo Alto is very small Palo Alto firewall, it's about 220 firewall. It's kind of the kids. It's kind of the baby. And if I'm going to put baby to handle the 100 kg weight, it's not possible, right? It can handle. Baby might be going to be injured. It's going to be hospitalized. He or she is not going to feel well. Similarly, Palo Alto is very small. This is small Palo Alto firewall. We cannot down get all routing. So we use the concept as a default route. They use the concept as a default route. In this default route, what we have to do that we inject one of the route here on the Palo Alto firewall 0.0.0.0 instead of the downloading all route, and will send everything next up as my ISP gateway. So this is how default routing is going to be there. Clear?
yes.
So in my Palo Alto firewall, where I can inject the default route, I'll go in the virtual router. We'll discuss what is the virtual router. And in this virtual router, you go in the default, one of the virtual router we have, and you see you have to define this kind of the default route. We have to do keep in again and again, but I'm showing you the fundamental concept, how it is going to be there. Or if I want to just say, I want to delete this, I want to create this default route from scratch. So I can put it here, default route. I'll put it default route for ISP. Okay. What is your destination? I'll put a destination 0.0.0.0/0, and interface is going to be my this one interface from where this internet is going to be accessible. And then I'll put the next hop IP address. For our case, the next hop is going to be 192.168.1.1. It's acting as ISP, and I'll click OK, and my job has been done. So first thing, you require the routing. Clear?
Yes.
Routing is also done, and security policy also we created. Now talking about the NAT. Before I explain how the NAT policy is going to be configured, we have to understand why we need a NAT and what is a NAT. So we have the two questions. What is a NAT? And second question, why we need NAT? Any idea you have? What is a NAT?
Yes. It is a bridge between the, let's say, the internet and then the WAN and then the LAN.
Okay, that's fine. But if you want to make more layman language definition or more simplified definitions, then how it is going to be possible?
The definition, I can't give definition, but the explanation is what, because actually we have the private IP and then the ISP IP, the public one.
Mm.
So whenever you want to connect to the internet, you need a public one, which is produced by the ISP. So therefore,
Mm.
that is where we use the port number. Normally, the NAT use the port number to translate such connectivity.
Right. Okay, that's very close. Okay. So we have a one problem, and for that we have a solution. So the problem is generally for the every company, they have the LAN network. Okay. In every company, even for your Wi-Fi network, you just check that you have the LAN network. This LAN is going to be connect with some ISP device. It could be your router, or might be it could be a firewall. Just think about firewall router, right? This device is going to make a connectivity with the ISP. That is the internet. So whenever you take the link, your WAN port having the public IP address, right? But LAN port you have the
Private.
private IP address. So generally, when you go for the definition, private IP subnet, we have the class A subnet, that's the private, and also we have the class B, and also we have the class C. Class A start the range 10.0.0 to 10.255, 255, 255. Class B start 172, 16.0.0, 172, 31, 255, 255. Class C start 192, 168, 0.0, and it goes to 192, 168, 255, 255. Clear?
Yeah.
So generally this always any company, even you go and check your computer IP address. If you're going to check, I have a Mac, if I go and check the if config, right? And I check my IP address, you're going to find my PC also have some private IP address. Let me show you. See, 192.168, 0.6. It's fall in the class C, right? So any company or any home Wi-Fi network, whatever you are using and where you are staying, you must have this private IP address, not the public IP address. Unless or until you just purchase the public IP address for your network. But always go and check either going to belong 10, 172 or might be the 192. So IP is going to be there. So the problem is on the internet only understand the public IP address. They not understand the private IP address. That's the problem. Means if you go in the internet cloud in 10 lakh routes or 1 million plus route, those are all public IP address. But in across the globe, every organizations, every home, they're using the same series of IP address. See, if everyone is going to reach with the same source IP address on the internet is going to be confused where I need to reply. Let's take an example. This there is two office. Let's suppose this is your home, right? Francisco, right? And you might be which country you are right now?
Qatar.
Sorry?
Qatar.
Can you spell out?
QATAR.
QUT. Okay.
AR.
Oh, Qatar.
Qatar.
Qatar. Okay, Qatar. Sorry. So you are in the Qatar, right? Let's suppose there is another land network. This is the land too. And let's suppose it's me. And I have the India. And I have the same IP address 10.10.10.10. And I also connect to the internet, let's suppose. And you also connecting the internet. Both are going to access the Google. Now, when the packet is going to reach to Google, one packet is going to come from Qatar with the source IP address 10.10.10.10 and destination is Google, right? This is the coming from the Qatar. Packet 1. Another packet also reached to Google. They have the destination IP address, definitely it's a Google, but source, here is source, here is also source, is 10.10.10.10. So now we receive the packet from the two country with a different LAN network, but when it's come to the Google, Google will be confused. I should send reply to this one or this one because they have the same source IP address. Make sense?
Yes.
It's going to be confused. I need to send where? Either I need to send my packet to Qatar or I need to send packet to the India because they are coming with the same source IP address. Reverse routing is going to be checked. And if the reverse routing is going to be checked and there is no, you have the means no unique route, you have the inconsistent route. So here it is going to be dropped. It is going to be confused and the packet is not going to be entertained. So to avoiding the such situation, what internet did, internet told no, none of the private IP address allowed on the internet. Allowed on the internet. None of the private IP, only public IP. And public IP address is going to be always unique. Clear?
Yes.
So the problem is, if you want to talk to internet with the private IP address, you cannot talk. So to solve this problem, we use the NAT. That is known as the network
Translation again.
address translation. Clear? They use the, so what they do basically. So whenever the packet is going to come, let me clear this board so I can explain in the better way. So what is going to be happen? Let's suppose we have the same situation, but this time I'm going to use the NAT here. So NAT is going to do that whenever your packet is going to be created. So your packet is going to be created here, the Qatar packet. We have the source IP address and they have the destination IP address. Let's suppose you want to go on the Google. Here is the Google. And Google DNS is 8.8.8.8. It's a public or private IP address, Francisco? 8 dot? It's a public or private? 8.8.8. You are on mute.
Private.
No, 8.8, how can be private? It's a class A, class B, or class C? 8.88. It's a class B, class B, class C. Means forget about class. We mentioned na private having only 3 range. It's not falling in 10, 172 and 192. So it is going to be your public. Man, you understanding or not? Francisco, where are you?
Hello?
Yes, yes, I can hear you.
Yes, I understand. I remember the 10 and then 172, 192. It is not falling on in that category.
Yeah.
So it's a public.
Yes, it's a public, right? So now you initiating the packet from your LAN network, right? And you want to go on the internet. So your source is going to be private. Okay, for initial point of view, when the packet is coming, this is going to be your, let's suppose this is my source IP address. This is going to source 10.10.10.10. Destination you're hitting to 8.8.8.8. This packet is going to land either router or the firewall. Now, before sending out this packet, the router is going to translate my source IP address as a unique IP address, because if this IP address reach to destination, the Google will not reply, because might be they're receiving the same IP address from the different location. So internet says any private IP address you cannot send it. So before sending out to the internet, what they will do, they will change your packet. So your destination is going to be same, but your source is going to be changed. Let's suppose you have the source IP address here public is 122.10.10.10. This is a unique public IP address. And here my source is going to be, let's suppose 144.10.10.10. This is my IP address. So now what is going to be happen? They will change my source IP address as a 122.10.10.10, and destination is going to be 8.8.8. Now this packet is going to reach to the Google. So Google have one packet which is coming from the Qatar. This packet coming from the Qatar with the source IP address 122.10.10.10, and destination is going to be 8.8.8.8. So packet 1. Similarly, this India is also going to send one packet with the same logic, but they will do the translation. So they have the destination IP again 8.8.8.8, but source IP is going to be my 144.10.10.10. So what is going to happen now? Google have the two packets, but when it is reply, whenever it is going to reply, so it is going to check. Let me use some different color. Hold on. Whenever they are going to reply, the Qatar packet is going to send, India packet is going to reply in this path, because their source is learning from this way. Your India packet is going to reply via this path because they have the unique destination. Because reverse is going to happen. So reverse packet is going to be generated, the source is going to become a destination, and destination is going to become a source. So this way, and this is going to be processed via this way. So this is how your uniqueness is going to be maintained between the source and destination. So NAT is going to be just do translation from private to public. In this scenario, we understand, right? But in overall, if I want to understand how my NAT is going to work, so let me clear this diagram, and I want to understand how this NAT is going to work. So NAT having not the definition to, it is just going to work from the private to public. I just showed the one of the use case how my NAT is going to work. It is going to be my translation from private to public. But you can do the translation from any IP to any other IP address. It's not mandatory the private to public. So if I just define the NAT, what is NAT? NAT is any IP to any other IP translation. This is the NAT. Means I have shown you how it is going to translate from source to destination. That's one thing. How it is going to be translated from source to destination, that is one thing. But it's not mandatory always you have to do a translation from the public to private or private to public. No, the NAT can be translated from private to public. That's one thing. The NAT can be translated from private to private as well. That's another thing. The third, NAT can be used from the public to private, and NAT can be used from the public to public. So any IP to any IP, any other IP translation is known as a NAT. Means if you are doing the NAT translation, means whatever the IP is coming as a source can be translated to any destination. Could be the private, public to private. It could be any combination. Means if you want to translate the IP address from one source to another destination, it's absolutely possible. You can translate the IP address. So in our case, we see the translation will happen from the private to public. Please mute Francisco. But it's not mandatory. If I'm going to translate private to private, it is also possible. NAT having only responsibility to translate my any IP to any other IP. That's all. Now, this NAT can be used for the different purpose. If I'm going to use the first purpose as a source NAT, that means my source IP is going to be translated. Source IP translation is going to be happen. If I'm going to use the source NAT. Another IP, another NAT type, we have the destination NAT. In this, we have the destination IP translation. Destination IP translation. The third one, we have the U-turn NAT. I will explain what is the U-turn NAT. In this also technically we have the destination IP translation. In the U-turn NAT also we do the destination IP translation. That fourth one we have the dual NAT. In the dual NAT, if you want to the source IP and destination IP translation, then it is possible in the dual NAT. You can do the source IP translation and we can do the destination IP translation. So these are the NAT. Basically, this NAT is used for the Palo Alto. And we are going to cover one by one all things. Now destination NAT will discuss, U-turn NAT will discuss, dual NAT. But if I talk the source NAT, again they have the three flavors. The first one, we have the static source NAT. The second one, we have the dynamic source NAT. And the third one, we have the PAT, which is known as the port address translation. Clear? So we have to do these all things. So now I hope it is clear. So we have the multiple flavor of NAT. And we discuss initially, if I want to go on the internet, I need the routing, which is in place. I need a security policy, which is in place, right? But we require the NAT policy also. And to go on the internet, always require the source NAT. If you want to go on the internet, we always require the source NAT. So let me create the source NAT and then we'll see how it is going on the internet or not. So policy we created. And I'm saying in this policy, you want to go on the internet. So that policy is already there. So I'll keep it here. I'll move this policy on top because I want to allow anything, not a specific destinations. I'll explain why it is created earlier. So you can just click it and move on the top. Just move this policy on the top. So this is going to be top of the policy. Now, if I go in the NAT, I need to create my source NAT and we have to define. So already one NAT is created. So I'll delete this NAT. Let me delete. I'll create from the scratch. So there is no NAT now and I have to create the NAT from the scratch. So how NAT is going to be created? I'll go here and I'll put the NAT as a source NAT because I'm going internet from private range to the public range. So basically I need to translate my source. So I'll go here, source NAT, and I can just put from trust to internet. And what is my original packet? Coming from trust. Okay, destination is going to be my basically untrust. Interface is going to be one. This is my destination interface. Okay, and source address is going to be 172.16.10.0/24. This is my original packet. Okay, now in the source NAT I mentioned we have the three flavor: static, dynamic, and PAT. So let me do as a PAT. We'll discuss what is the static and dynamic NAT also, but I'm just showing you how it is going to translate it. Now, if I go here and I just select the interface PAT, I'm just doing means port address translation on the single IP address. So I selecting this IP address and there is IP, which is my this one. We'll do the deep dive on it, don't worry. But I'm just going to showcase how internet is going to work. So now we have all three requirements to go on the internet: NAT, routing, and policy. Now I'll commit it. And after commit, we'll see how the traffic is going on the internet and how the NAT is going to look like in the session table. Clear, Francisco, till here? Man, you understanding?
Yeah. Correct.
Okay. Let's wait for the commit, then we'll move to the next. So commit is in progress. We'll see that after. It's take time sometime, okay? You don't have to worry. Okay, so almost done. And now if I go and try to simulate the packet, how it is going to the internet. So I'll go on this particular PC. And this PC have the already IP configuration. So let me show you. If I go on the IP configuration, let me show you the IP configuration of this PC. So you go in the adapters, go on the IP. So you can see this is the IP address, subnet mask, and the gateway. So if I want to trace the packet, you go here and you want to just first ping the global DNS. It should be reachable. Just wait. It's not pinging. Very strange. Let me try to ping the gateway first. 172.16.10.1. Yeah, it is reachable. Let me verify the policy. NAT we are doing. That's fine. This is the 172.16.10.0 translated we are doing on this interface. That is also fine. I hope we not make any mistake. Let me check the my policy. Is policy also saying anything coming from the this source 172.16.10.0 going to untrust? It is okay. We just allow the WhatsApp. So here is the mistake. Okay, application we allow in this policy WhatsApp. That's a mistake. I mistaken, not clear. So you can do the such mistakes. So because of that, it is not allowing the ping because we allow the. So I need to make any. Okay, so let me check everything. I'll make application default is also fine. There's no problem. X0. Let me recommit it. Okay. So there is one issue. Application I mistaken. Select the WhatsApp. Let me recommit it. So I will go and commit again. And I will apply the continuous ping to this particular IP. And let's see. It's going to take a little bit time, then it is going to be commit. So commit is happening. So probably you can see this must be start pinging. You can see. So this PC start pinging all the internet. So we make the mistake, but now if I want to verify how the NAT is happening, so you can go and check whether CLI or GUI both. So let me show you the CLI basically. So I will go SSH 192.168.1.137. And okay, so I'll put S and I need to give the password. And you'll see. So if you want to see the source session all, you're going to find this. This the ping is happening, and this is the destination, and we are doing the this session we are going and we are doing the NAT on this IP address 192.168.168, and this is the source NAT is happening. So now we understand how the NAT is happening, and exactly you can find in the your logs also. If you're going the log, you're going to find the packet is going to be on internet, and they have the NAT IP address. That is source NAT is going to be happen. So right now the NAT option is not available. Let me show you how NAT is going to be there. So you just go down in the log. You want to see that source NAT and see here source NAT IP address and port. So if you click here, you can see the original source is this, translating to this, and then it is going to destination. So this is how you can check that. So I hope we understand some basic foundation how the NAT routing and policy is going to work. We
Yes,
have
sir.
to do further deep dive on it. Okay, Francisco? Clear?
Yes, sir. Yes.
Good. So thank you so much. Okay. See you.